Hi everyone, in today's lesson we're going to talk about a concept called the intermediate value theorem. Now before I state the theorem, I just want to say that this IVT theorem is really old mathematics prior to where a calculator was invented. So the person that came up with this theorem figured this out before calculators were even here. So this is a great concept that will likely be on the no calculator part of your exam. So it's definitely something that we need to cover. So what's the definition? If f of x is a continuous function, f of x, over the interval from a to b, then there exists at least one c in between a and b such that f of c is also between f of a and f of b. Okay, so what do I mean by that? So let's just say I have a continuous function, and the function maybe starts, here and ends here, right? This is a piece of a continuous function. We'll say the interval that it starts is from a to b. So what the theorem states is that there's going to be a c value in between a and b. So I'm going to put the c here. It doesn't have to be in the middle. It's just that there is a value c in between a and b such that f of c, so that just means the y value when I'm at the curve, right? So f of c is the y value when x is c. So there exists this y value such that it's in between f of a and f of b. Well, f of a is nothing other than the y value when x is a, and f of b is the y value when x is b. So they're basically just saying there's going to be an x value in the middle that has the y value that's also in the middle somewhere. Now, this could be true when the y value at f of a is smaller than f of b. And this also is true if I switched it. So let's just say my curve, I don't know, looks something like this. Here is my a, and here is my b. And here, f of a is larger than f of b. And the concept is still the same, that there is going to exist a c, so I put the c here, such that the y value, f of c, is in between f of a and f of b. So how do we use this? Well, we use this to prove existence of roots and or solutions. So let's just scroll down to the first example. So I'm giving you a graph. So obviously you can answer the question with the graph, but you're not going to get that. So you're basically going to be given this function. And it says between which two x values does the function have a positive zero root or solution? Explain why and use the IVT to prove the existence of this root. So let's just see, and we can use the graph now to answer. I'm looking for a positive zero or a root. So that's a negative zero. That's 0. And this is 2. So between which two x values does this 2 or my positive root exist? Well, it looks like it happens between 1 and between 3, right? Here's 1, and 3 would be somewhere up here. So we need to prove that using the IVT. So we've got our a and b values, right? Here's my a, and here's my b. So we know with the theorem we need f of a and f of b. So let's just start by rewriting the function. And f of a, or the a value is 1, we're going to calculate. So 1 to the third plus 1 squared minus 6 times 1. So 1 plus 1 is 2, minus 6 is negative 4. And that proves here, right? That's my y value. And f of 3, since we can't see it on the graph, we can find it. So 3 to the third plus 3 squared minus 6 times 3. So what's this? 27, 9, and 18. So that gives us 18. So if we were able to see when x is 3, the y value would be up here somewhere at 18. So there will exist some c value in between negative 4 and 18. So negative 4 and 18. So doesn't that prove that if I'm going from negative territory to positive territory, that the curve is going to pass through the x-axis, thus creating the existence of a root, right? So that's kind of all you need to know. So as far as an explanation, we can say, according to the IVT, intermediate value theorem, there exists a C such that it's between 1 and 3, right? We exist this C value between 1 and 3. We don't know it's 2. I mean, obviously we do from the graph, but if the graph wasn't here, we don't know that it's 2. So it's between 1 and 3, such that f of A is less than f of C, which is less than f of B. So what that says is, here is your f of A value, the -4, and up here is your f of B value, right? The y value here, the y value here. There exists an f of C in between. And now, since they're technically asking for the existence of a root, you have to state the fact that you understand that it went from negative to positive, therefore it will pass 0. So you could say f of C must equal, at some point, between, and then you can say -4, which is the y value, and the other y value is 18, and you can just say, because the graph travels from a negative value to a positive value. Crossing y equals 0. All right, I know that was a long explanation, but that really explains that you understand the concept. Let's move on to another example. Okay, so example number 2, verify with the intermediate value theorem and use that theorem to find C. Okay, so they're asking us to give us this equation. Can we determine that the f of C value will equal -1 from here to here and find the C? So we always have our interval from A to B. So let's find f of 0 and let's find f of 3. So I'm just going to plug in 0, and that's easy, that's -2, and then we'll plug in 3. This one might be a little more work. So 27 minus 9 plus 3 minus 2, and that gives us 19. So does it work that there will be a C value that'll be -1? Let's see, -2 and 19. So if you wanted to draw a little sketch of this, when x is 0, we're at -2. So you could say here. And when x is 3, we can exaggerate this, call this 19, right? So the curve is going from here to here. So will there exist a C value where the y is -1? Well, yeah, that would be right here. Here's -1. So whatever this is, that would be my C. So we have the y value of the curve. We just need to find the x value. So all you're going to do is plug into here, and you're going to plug in your y value of -1 and find your x value, which is your C. So -1 equals x to the third minus x squared plus x minus 2. Now this is a factorable equation, so we need to add the 1 to set it equal to 0. So we can factor by grouping to take out an x squared. Here we could take out a 1. And we're left with x minus 1 and x squared plus 1. We can do a nice little t-chart. We get x equals 1 on this side. This one, I believe, will have imaginary roots, right? When you subtract the 1, it's i's. So this one's plus or minus I, which would not be necessary. So x equals 1. So does that make sense? Is 1, positive 1, in between 0 to 3? Yes, absolutely. So if we wanted to write a statement here, you would say, verify using the IVT. So there exists. So according to the IVT, intermediate value theorem, there exists a C, which we know is equal to 1, such that the C value is between 0 and 3, And the f of c is in between f of a and f of b. And that's it. That is the IVT theorem. So now example 3 is applying the intermediate value theorem with a table. So a table is much easier to do. So I'm actually going to have you guys try this all on your own. There's a couple parts here, so try to see what you can do. Try to see if you can explain your answers even where it doesn't say explain. Like here it's asking you to explain, but here it's not. Try to see if you can write down explanations. Try to see if you can do it, and we'll start class by going over this one tomorrow. All right, have a good night.